you were able. But before we begin today, I want to thank each and every one of you for being here as a co-chair for this event, along with my co-chairs Ray Toll and Dan Sternlicht. Just again, thank you. In this quasi-post-COVID era, it's still quite a challenge to put on some of these events. So I greatly appreciate everyone that is here, either in person or on our virtual platform. So again, thank you. But over the past 2 days, we've had some really rich discussions around the theme of resilient coast. But we've also really focused on our kind of themes here, our focal areas of adaptation and this whole of government, whole of community approach. And these were really exemplified by many of our panelists and our plenary speakers, and we're really going to build on this today as we talk with our chief scientists of NASA and NOAA, so I'm so proud that they're here. And then we also go into a great panel on partnerships, so please join us throughout the day. But just as valuable, we've had a great opportunity for some really exceptional early career engagement and networking. So to all the teams that put together our Emerge panels, our morning breakfasts, thank you for doing that. It's been excellent to work with our early careers, and this is the point where we can really bring together all of this knowledge and propel it into the future. And speaking of the future, as we close Oceans 22 today, we bring together the innovation and the partnerships to really look at the future. And we are honored to be joined by Dr. Sarah Kapnick and Dr. Kate Calvin, Chief Scientists for NOAA and the Chief Scientist for NASA and Senior Climate Advisor. So what an incredible pair we have today. Throughout the week, we've heard that achieving our ocean goals cannot be accomplished alone. And today, Kate and Sarah will discuss with us both the Ocean Climate Nexus and their visions for the future as leaders in their respective agencies. So Sarah, Kate, please join me on stage. So Dr. Kapnick is responsible for advancing policy and program direction for NOAA's science and technology priorities. She has extensive experience at the intersection of climate science and economics. And most recently, she served as the managing director at JP Morgan in the role of senior climate scientist and sustainability strategist for asset and wealth management. Her work has spanned seasonal climate prediction, mountain snowpack, extreme storms, water security, and climate impacts. Dr. Kate Calvin was appointed as NASA's chief scientist and senior climate advisor by Administrator Bill Nelson in January of this year. As chief scientist, Dr. Calvin advises agency leadership on the agency's science programs and science-related strategic planning and investments. And as senior climate advisor, she provides insights, recommendations for the agency's climate-related science, technology, and infrastructure programs. Her research has stimulated the interactions between global resources, focusing on the impact of land, water, and energy, used through an environmental and socioeconomic lens. Also joining us on stage is Joel Scott. Joel is the program scientist of NASA's Ocean Biology and Biogeochemistry program. Joel will be helping today to moderate this discussion, and we'll be taking questions from the audience. So please be prepared to ask some questions. We've got this exciting pair here. This doesn't happen often. And in the virtual platform, we'll also be monitoring that for questions as well. So please join me in welcoming this dynamic pair. Thank you.
I just want to thank you, Laura, very much for inviting us. It's truly my honor and privilege to be here. I'd like to thank MTS, IEEE, and of course the conference organizers, hosts, and all of the folks who have helped bring us together this week to have these important conversations. I'd also like to thank all of you for taking the time to be here in the audience and hear what these two visionary women have to say. I'm really honored to be up on the stage with both Kate and Sarah. They're working to identify and set strategic priorities for two major federal agencies here in the US. And my goal over this next hour is to really keep it conversational. I would like to imagine us all sitting by a fireside or perhaps the ocean side, since that's this meeting, and just having a casual chat. So as Laura mentioned, we will be taking questions and comments from you all in the audience, so be getting those ready. But I guess we're going to start first with a little bit of a reflection on this week. I feel like over the past 2 days, we've heard some incredible discussions focused on the planet's oceans. So would each of you please speak briefly on your roles and how observations from your respective agencies are informing our current understanding of the oceans? And we'll start with Sarah.
So thank you, and thank you for having us both on the stage here together. Right now, the current state of observations, we have so much that we are doing, from buoys to being able to have gliders in the oceans, autonomous vehicles, and then also using satellite data to understand the ocean. And it is critical for us for the monitoring, but also for our capabilities for forecasting, for weather forecasting, but also seasonal prediction to decadal prediction, to have really good observations of the ocean, not just at the surface, but also deep into the ocean, of heat content, of temperature, of salinity. And the future of being able to continue to deliver and improve our forecasts, improve our predictions, requires expansion of the observing system of the ocean to be able to build up those capabilities even further, improve our predictive skill. So I see the ocean is absolutely critical to all of NOAA's mission, from even in our weather forecasting on our climate side and ecosystems through fisheries. So the ocean is critical to all the things that we do at NOAA.
Awesome, thank you. Kate?
Yeah, thank you. And I'd also like to thank for the invitation to be here. I'm really excited to be here and talk about that. So I am NASA's chief scientist and senior climate advisor, and we are a space agency. And one of the advantages of that is we get to look back at Earth from space. If you think about some of the pictures from the Apollo missions, you can see the Earth. And what you see is a little blue ball. So it's an ocean planet. And what we know about it is that the ocean is a really important part of our climate, of our ecosystems, of our lives. So ocean absorbs a lot of the heat that's put into the atmosphere. It also absorbs a lot of carbon, so it has influence on our planet's climate. And how much the climate might change in the future depends on how much more carbon and heat the oceans can store. And we look at all of these things from our satellite observations. So one of the really nice things about satellites is that we can see all of the Earth. So in even hard to reach places, we can see all of the oceans around the world. But we pair that with some of the ground-based observations and the floats that Sarah mentioned to get a more complete picture. So we're seeing not just the surface, but the depths. We're not seeing just the coast and where we are, but we can see the far reaches of the ocean with the satellite information. And it's really important for understanding where we are, and then we pair that with models to understand where we might go in the future.
Awesome, thank you. And of course, I mean, both of you touched on climate. So my next question is going to get at that as it relates to the ocean and aquatic ecosystems. We are seeing longer and more intense marine heat waves. We're seeing increasing ocean acidification. We're seeing an uptick in both intensity and duration of harmful algal blooms. And we're seeing shifts in different trophic levels, both spatially and community composition, from microscopic bacteria to large fisheries. So what do you see as the biggest opportunity for ocean observations and the ocean climate nexus more broadly? Kate, would you care to go first?
Sure. So, I mean, first of all, we have a lot of observations now, and we've worked together on putting out reports that can provide information about how planet's climate is changing. So we put out an interagency sea level report earlier this year, and so we can look at how much sea level has risen in the past, how much it might rise in the future, which is really important for coastal communities. We can also look at things like harmful algal blooms, and we have a number of satellite observation systems in plans going forward that'll give us better understanding of ocean dynamics and ocean biology, both of which are really important for climate. So I mentioned before that oceans absorb heat and carbon. Well, a lot of how much heat and carbon they can absorb depends on the circulation. So it's absorbed into the surface, and then how much the ocean mixes tells you how much more you can take up in the future. And so we have some missions coming up that will help us better understand those dynamics and better prepare for those.
Yeah, and I would add to that there was this belief, even not that many years ago, that there would be these gradual changes in fisheries potentially brought about by climate and the climate changes in heat content. But these marine waves are happening at a much faster pace than originally thought, even 5 years ago, and are more intense. And so now modeling that, observing it, understanding what is the likelihood in the future, what have we missed in our global climate models, often which have extremely low oceanic resolution, so they don't capture these high magnitude events as well. Like, what is it that we need to push forward on that modeling to be able to predict these things going forward for the marine heat waves? And then how do we connect it to our ecological models, our fisheries models, so we can better predict these things on long projection timescales, but also can we start predicting them on seasonal timescales or multi-annual timescales so we can have some advanced knowledge? And then all that research that we need to have happen, how does that start moving into our fisheries management? How do we manage these fisheries in light of climate change? And that is a major effort right now ongoing at NOAA, is trying to figure out how do we start managing to climate change to the fisheries. And so that requires the observations of current state to be able to predict them forward on weeks, months, years timescales. But it also requires new systems to be built around how we start managing these things in this changing environment.
Thank you so much for both of your answers. And I noticed, Kate, you touched on the interagency world. And so I would love to hear both of your visions on how the two agencies, NASA and NOAA, can work together to really collaborate and advance the state of the science in terms of the oceans and climate change.
I can start with that. Yeah, I think, interagency partnerships are really important, and we have a long-standing relationship between NASA and NOAA. NOAA's weather satellites are built and launched by NASA for NOAA, and so we've been doing that for a while, and then we also have been putting out complementary temperature updates, and then the sea level rise report. And I think a lot of it is when we think about our capabilities, we have complementary capabilities. So in the sea level rise report, what we can do is use our satellites to understand historical sea level rise, including what's contributing to it, how much of it's from ice sheet melt versus other factors. We also have the ability to look into the future and give sea level rise projections. NOAA has a lot of capabilities on coastal and flooding, which I'll let Sarah talk about, but a lot of what we end up doing is, we provide, basic research and satellite observations for NOAA and other agencies to do parts of their missions as well.
Yeah, and that point on the interagency grouping, it's that interconnectedness and the assimilation of all that different type of data, which using the word assimilation can also have very specific meanings, but bringing together all of the different data streams that we have. The satellite record, we have it for a certain period, but then we have the buoys that go back to the 1800s in some places around the world, the tide and sea level height. And then like down the road here in Norfolk, I looked it up of what has sea level rise been over the last few years. And the measurement station that we have there is from the 1930s. And so since the 1930s, we've had data in this area. And so we've had 0.47 meters of sea level rise here, and we'll have another foot roughly or more in the next 30 years. So we can take all of those data streams, all the heights that we actually have around the world of point locations with that satellite data to then remap it to the entire globe, plus all the coastal information and modeling to be able to understand from the global scale, which gives us an understanding of long-term trends, but and where it's going in the future, but then at the local scale, so where people actually need the information for actionable change and planning and coastal resiliency planning. And we couldn't do that if we didn't have the satellite data coupled with everything else to have this really full picture and reduce the uncertainty of what our projections for the future are. And so it's really critical for us to all work together to bring all of this together to reduce that uncertainty of what the future holds. Because ultimately, decision makers, urban planners, infrastructure planners, they need that lower uncertainty to make those investment decisions to be able to adapt to this changing world.
Fantastic answers, thank you. And then you both touched on kind of an integrated ocean observing system. You talked about this data record that goes back before the satellite era, and then both agencies have satellite missions that they support and they work obviously towards. And so I'd love to think and hear more about how do we connect those in situ observations, those suborbital observations, those satellite observations that have been around for the last few decades. How do we start to connect those? I know you've touched on modeling, but are there other strategies that we can use to really bring together the full integrated observing system that both of the agencies have in place?
Yeah, I started to say this with data assimilation of what is the state of the world at this point or in the past, to be able to use that to run with to be able to put all the information together, to be able to have a picture of what the world is or has been in the past, and then we use that for our predictions, projections, and forecasts of the future. And so we need data structures to be able to bring all the data in and then pull it all together. And so it's not just creating one data stream and putting on one server in a different format than all the other data streams. And so there's new data standards, new ways of creating the architecture to put all of that information onto the cloud so that it is all accessible, and then we can bring all these things together in a very fast time frame, particularly if we want to use it for seasonal or daily weather forecasts.
Yeah, so I completely agree with Sarah, and I think this is, part of, we have models that do this data assimilation. So they include physical relationships in them, and then bring in different observations and provide a more complete picture. But I also want to think back on, what these different types of observations are and how they work together, because they are really complementary. So we think about, and Sarah's started down this path earlier, but I'll just go a little further on it, is, think about satellites. They're giving you complete coverage of the Earth's surface. So they have really, cover all of the space, but they only go back so far in time, and there's a limit to what we can see from space when you come to sort of depths or precision. But we can combine that with things like the Argo floats, which don't cover the whole world. They have just in particular points, they're not as global coverage, but they can go into depth. And similar with tidal gauges, we have longer time series with tidal gauge, but we can combine all that together. And we also at NASA use some of these field campaigns or airborne campaigns to get at process understanding. So we've looked into, can we better understand this particular process that's affecting something by using a targeted higher resolution campaign, and then you combine that with the satellites and the other observations that you have.
Yeah, and if we want to get super technical now, with those types of data simulations, with the satellite data, but with the Argo floats, then with the gaps of the observing systems, particularly in the Southern Ocean, you then see through those data simulation methods with those models, okay, there's much more spread in some of these places in the world, and those are the places we need to constrain with more physical assets. So that is why there's programs around trying to improve our number of Argo floats and measurements that we have in the Southern Ocean, is that is a critical place for the carbon, for the ecosystems, but also for our understanding of global ocean heat uptake. And what the future holds requires us now to do more observations, and it won't there be necessarily new satellite data, it'll be new physical assets that we have, these uncrewed systems, but then it will come back to how do we assimilate that? How do we bring all that data together? And that's where the interagency work really needs to happen. Where should we target those measurements? And then how will we use them once we have them?
Oh, that's fantastic. So I pick up on both of you talking about data and cloud technologies and also data accessibility. So one of the themes that we've heard over the past couple days here at this meeting has been the blue economy. And so when I think of the blue economy, I can't help but think about stakeholders and decision makers and more applied users. So you're talking about exactly how we can advance the science, how we can better understand what ecosystem changes we're seeing, what climate's impacts are, but then how do we also try to reach that new group of stakeholders? And I'd just like to hear some of your perspectives perhaps on initiatives at each of your agencies that might be targeted at the blue economy or that might be trying to reach a new audience of stakeholders and decision makers, and how we can make data truly actionable for a thriving future for humanity.
Yeah, so one of the 3 pillars of the NOAA strategic plan that was recently released for the next couple years is not just the blue economy, but the new blue economy. And it is trying to do just that, reach new sets of stakeholders around the blue economy than previously. So traditional blue economy will think of just the aquaculture, the fishing lines, and fishing. But new blue economy also extends this with this idea that we all know from the technological side of ocean sciences that observing systems in the ocean are really critical for understanding climate, for being able to drive projections of climate and understanding seasonal predictions and what the future holds in terms of extreme weather, seasonal climate as it may unfold, which is really important for building everything else that we have in the weather and climate enterprise. And so the ocean blue economy isn't just the physical assets that you see in the ocean, but it also is this data economy that is building from what we have. And so our agency is trying to expand on that and explain that there is much more to this that we need, and trying to develop it out. And through funding that we have in IRA, in the recent bill, we have $2.6 billion that is going to coastal resilience. And many programs within the new blue economy, we're developing them up. There will be announcements in the coming months of what we're going to be spending on it exactly. But the goal is to try and try to advance the new blue economy even further, which over the last few years has actually been growing at a faster rate than the traditional economy as well.
It's a very exciting time. Kate.
Yeah, I actually want to touch on data accessibility and open science more generally, because this is a big thing at NASA, not just with oceans, not just with Earth, but with all of our missions, is we're trying to make sure that people don't just have the ability to get the data, but actually have access to it in a different way. So all of our information is publicly available, but if you're not really technically familiar and don't have large computers, it can sometimes be really hard to use. And so we've been taking some steps to move towards that. So we have an effort to put all of our tools and resources, make those publicly available too. So not just the end product, not just the raw satellite data, but the steps that we take to process it as well. And so we've been working on that. And we actually, in our equity action plan that went out this spring, we had a couple of areas specifically related to this, like moving data to the cloud, because not everyone has access to a supercomputer. We're also going to put out some trainings on our Earth science applications in Spanish language to try to reach a broader set of the population. population. And then the administrator announced about a year ago, and we've been working on formulating this now, the concept of an Earth Information Center, where we bring all this together and engage with people. So we show both what we know about the Earth, but also hear back what people need and try to make that information available. Because we're moving to a period where people need information to make decisions, and trying to make that easier, I think, is a big goal at NASA and all the other agencies. And so we work with NOAA and others on this as well.
Yeah, really that equity piece of making sure that everything is accessible and everything that we do, the products and services, not just in our operations and our employees, but also our work with the public and making sure that everything is usable for everyone. Touching on that point too, with trying to work in the communities, particularly around New Blue Economy, NOAA through our Sea Grant program engages with local communities, particularly right now in coastal resilience and building coastal resilience. And I think we have people in every single state, and we even have operators in Guam. And from learning from this of what's happening, particularly in the island nations or places undergoing rapid transition like Alaska and the Arctic, we are finding increasing need for help on figuring out, okay, how do we deal with sea level rise issues, with erosion issues, with our aquaculture changes? And so we have those local community groups through Sea Grant putting funding in to be able to do these assessments of coastal resilience and what needs to happen so that they can make those plans with the NOAA data and information that we have. And then once those plans are made, it's not just NOAA that funds what they do next. They can then go out and they can seek municipal bonds on the bond market, or their local companies can actually seek private debt through the private debt markets. And so building up these plans and using NOAA data and NASA data to be able to explore what your exposure is and what the expectations for the future are now unlocks new types of capital to try to build coastal resilience and have the money come in to be able to do that. Because doing that in advance of major events reduces the risk, reduces the damage, and helps the regions be able to bounce back a lot faster.
Yeah, just one last thing that, as you were saying that I was thought of is, one of the things for us, NASA's not just a producer of information, we also use it. So we have centers and facilities along the coast that are vulnerable to coastal change and are already actively taking steps. We have dune restoration at Kennedy Space Center and at Wallops Flight Facility. And so we're also thinking about, as we're producing information that can help other people make decisions about coasts, we also have to think about our own structure. And I think that gives us a real learning opportunity where we bring scientists with facilities managers together and have those conversations, and what we can learn from it, I think, would be really valuable to people.
And that even goes back to the original question on interagency working groups. We even have an interagency working group of all the agencies are starting to share, what are you doing? How are you doing it? And it's NASA and NOAA that we have the in-house science capabilities, so we're actually doing a lot more than other agencies that don't have our science capabilities, and we're now sharing that across the entire federal government of how to start thinking and quantifying these risks.
No, I really appreciate the dialogue here. Our oceans are global, and they affect more than just any one country, and so it will require global solutions. So thinking about open source data and how to be equitable and environmentally just, I think are really, really important topics. I did notice that both of you touched on extreme events, and so it's really hard to have a discussion about climate change and not talk about extreme events. So I have a question here that I'd like to ask both of you that touches on that. So the link between climate change and frequency as well as intensity of extreme events is increasing according to the most recent IPCC reports. It's an Intergovernmental Panel on Climate Change. How are NOAA and NASA improving our understanding of extreme events, and more importantly, working to help communities to better understand and respond to the compounding risks associated with climate change?
Well, I think some of this on extreme events is just observations of them. So, knowing where there are heat waves, we can see that from our satellites and ground-based observations, and knowing what those events are is helpful to sort of, as we're trying to understand the link to climate, you need to first understand the frequency and the intensity itself. But then, we've talked a lot about observations here. We also at NASA and at NOAA have modeling capabilities. So we both have Earth system models that can help us look at, how is the Earth changing, and how might it change in the future, and how does that link to extreme events for the ones that we can understand? And so we can provide that kind of context. And then back to the earlier discussion about open science, like everything we do, we have to get that to people. And I'll just say this is more terrestrial based, but we have a disasters response team that does this near real-time information to people during extreme events. A lot of the work we do is around wildfire, but we also have capabilities in other spaces.
And this question is close to my heart because this is when I was a bench scientist, was a major part of my research. And so with all the observing systems that we have the truth of what we've experienced in the past. And so we have that information to quantify extremes and how they're evolving over time in the past. But that gives us a lot of uncertainty because extremes by definitions don't happen very often. And so particularly for the more extremes, and the more extremes that were happening right now that might be outside the envelope of whatever has happened in our recorded past, it brings this question up of how do you start quantifying the evolution of these changes in extremes? And the only way we can really truly do that and have a better understanding of the future and even of the risk of extremes today is through modeling, is through the global climate model capabilities that we have, and to be able to make hundreds or thousands of years of data to be able to run with projections, but also of today, to be able to understand and quantify how those risks are evolving in time. And that allows us to even reduce the uncertainty of understanding what the risks are today. And so the models are extremely important for being able to do this, but they're only able to do that with the rich observing network that we have. And so that's why it's important that we continue to advance these models to be able to capture those extreme events, which typically means we need to move them to higher resolution. We need to make sure we capture the processes that are in those models, but that we also need to make sure that our observing systems are giving us the information we need to be able to understand them as well, and to be able to monitor them over time to give us those ground truths, but also to be able to constrain the bounds of the risk with the observed records.
So you touched on a really interesting point in my mind, and that's humans have a great capacity for renormalizing our baseline. By talking about extremes, you're right, by definition, they don't occur that often. But as our average, as the mean signal is shifting, how do we still try to help motivate and catalyze innovation and enthusiasm behind climate mitigation and adaptation efforts through data and accessibility when it comes to thinking about extreme events?
Like the interagency across government, we put out CAMERA recently, resilience.climate.gov. This goes to your last question too, of how do communities get access to this information. And so that is based on one of the sponsors here, ESRI, was helping with the mapping data is in there to be able to collect all the data from across all federal agencies to be able to explore those extremes, explore how they're changing, and be able to see it. And so it gives accessibility to a new audience. It's the communities, city planners, urban planners, also small businesses often actually have knowledge in that specific mapping software, so it's very accessible to them. However, more sophisticated groups that then need that underlying data to quantify their specific risks of the physical risks, but then overlaying their assets or their business activities or their community activities or international activities, that requires more sophistication and deeper data dives. And so that's why our open source data, our AI-enabled data, the data on the cloud becomes so critical so those groups can also have access to the full suite of what we produce as well.
Yeah, I would just say, as a science agency, our job is to provide scientific information to people about, what's happening in the past and what might happen in the future. And Sarah mentioned CAMERA. There's a few other tools like that. And one of the things that's nice in there, I was just looking at CAMERA yesterday, is they show you in the future for different emission scenarios, because it does, how many more extreme events you have, depending on the extreme event and the location, depends on how much more warming we have in the future. And we know from science that the warming we're experiencing now and how much more warming in the future depends in large part on greenhouse gas emissions. And so that's one of the things that we can do, is just show where we know where the what the different possibilities are, both what's happened in the past and what might happen in the future, and just provide that information so you can see here's the level of extremes, or here's the level of sea level rise now and in the future.
Thank you both. And I realize I have been dominating the conversation and the questions here, but again, we do want this to be conversational. So if anyone from the audience wants to ask a question, please make your way to the microphone. Those of you who are joining us online, I believe Laura Rogers has the capability of relaying those questions or reading them for you on your behalf. So again, please, we welcome those as well at this time. It looks like we do have a question in the room. Go ahead. Please introduce yourself as well.
Good morning. Thanks, Joel. I'm Veronica Lance. I'm with NOAA Coastwatch. Joel, you mentioned biology earlier and the changes. I'd like to bring to our attention as a group that with NASA as the space center agency doing the experimental development of new technology in space, and NOAA the operational agency, NOAA Fisheries has needs for the new technologies that NASA is promoting. So as NOAA plans for future operational satellite missions, I'd like to hear about what our plans are to make sure that we incorporate the best technology we have today as we're planning out for future polar orbiting and geostationary satellite observations, to make sure that we in NOAA are not using old technology for missions that are out 20 or 30 years. Thanks.
It's a fantastic question. Thank you, Veronica. Kate, would you care to take a stab at this one?
I'll take the first part, but I think a part of that was about NOAA satellites. So just on the NASA side, you're right, part of our job is innovating on technology and innovating on observation systems. And so we do have some ocean observing systems in plans, some in the near term, some in the farther future. And I'll just mention, because you were talking more about biology, we have a PACE satellite that's targeted for early 2024. This has got an ocean color instrument on it. So it's going to be able to see ocean color with really, really high resolution so that we can understand phytoplankton and harmful algal blooms in that. We're also working on part of the way that NASA works in terms of what we build and what we launch is driven by a National Academies process that we call the Decadal Survey. And what the National Academies does is they pull together, what are the most pressing questions about the Earth, and then NASA's tasked with turning that into a satellite mission or program or sets of missions. And so we've been working on the next generation of Earth-observing satellites called the Earth System Observatory, and included in that is a mission targeting on surface biology and geology that includes information about marine life.
Yeah, and on the data side, at NESDIS, our line office that also has its own satellites but also brings in satellite data, we have reviews constantly of what is available and what is going to be coming online in terms of these observing systems to see what meets our needs for our mission. And so they're analyzing what the missions are coming out of NASA, but also what's coming out of Europe. What are we planning ourselves? What is even happening in Asia? What is going to go up in the sky, and what are they going to measure, and with what precision? And then with that, it's not just the agencies that are doing it. There's now also a private sector, and I know there's some people from the private sector and observe it in satellite here today. And we're also looking at what they're going to be providing. And that data often we have to purchase. And so we're looking at all of these things and figuring out, okay, for our mission, what is it that we need? What will provide us with the data we need? What will provide us the reliability? How are we going to access it? And what are the costs of all of these things? And so we're trying to optimize across all of those to make sure that they're integrated in. And then additionally, we have the researchers that are trying to research and figure out, okay, how are we going to start using this? What does it improve? And then how do we transition that into operations? And so there's a multi-tier level of engagement and discussions and decision-making around how are we going to use the data, how are we going to most effectively bring it in, and then how do we operationalize it and ensure that once we operationalize it, we have something that will continue in time so we don't lose it at a certain point.
It's fantastic. Thank you both for answering that, and thank you for the question. I think it is really important to think about how the agencies can work together, how technology development at NASA can be tested and developed and iterated upon, and then how that can be made operational at NOAA. So again, great question. Thank you, Veronica, and thank you both for your answers. Go ahead from the audience.
Good morning. Stanka Willis, President of Marine Technology Society. Dr. Kapnick, Dr. Calvin, thank you for being with us today. I'm going to actually go a little bit further, ask you to talk a little bit further on the topic you just raised, Sarah. So we have seen a significant increase by private companies in platforms, in satellites, and even in the data services. So might you talk a little bit more about that convergence and of that ecosystem of industry, government, and academia to actually be providing those sustained ocean observing?
Who wants to go first?
Sure. We will look at everything that's available and figure out what we are going to incorporate. And we're even developing through our small SBIR program, through our technological partnership office, particularly with these new startups that are starting to provide information, we're giving grants to be able to help them expand, but also try and start using that data. Use that data experimentally. And it's a shift in what NOAA has done previously because we didn't want to necessarily take experimental data originally and try and figure out how it might work. But we're trying to do that now to see, okay, if these technologies expand, if the market of this grows or this one technology takes off, what does that mean for the future? How will it scale? How will we be able to use that? And so we're trying to think on these long-term timescales and give some of the money early up front, even if it's risky now, because we're trying to innovate on the use of that data and also be able to plan for it in our long-term planning. Additionally, I think we'll see a lot more in our private sector engagement around this because of this explosion in the commercial sector. I will add, however, from my experience previously at JP Morgan, investors are really interested in investing in this stuff. But but there needs to be a diversity of ways that these companies can make money, that they can provide the information, not just to the federal government necessarily, but also to a broad group. And so I think we're at this time also in tightening markets where it'll be really interesting to see what happens to the growth of this industry right now, because there's some uncertainty. And so we are going to try to incorporate everything we can and support the development of that commerce as much as we can. But there's going to be some risks with that. But we're willing to take that risk, which we haven't been previously.
Yeah, I mean, I think it's an important point that this is a different world than it would have been decades ago. Both, we have private companies with Earth-observing satellites. We also have private companies providing data products. And at NASA, we work with private companies throughout our space, and we work with them in different ways depending on the particular application. So we have a commercial small sat data acquisition program where we buy data from some of these small commercial satellites, and we make it available to NASA scientists and to in some cases, to other scientists within the U.S. federal government. So we buy it on behalf of, for use by others. And so we do that very closely. We're also looking at, some of these analytic companies that are coming up are relying on data from NASA and looking to better understand what they're doing and how we can work with them and how we can engage them. Because it is, there's a lot we can learn, there's a lot we can do with that information. We've been leaning forward on the data acquisition side, and I'm sure there's more that we can think about.
Yeah, and even there's nonprofits even entering the race now with their own satellite technology or satellites as well. And so the improved increase in engagement that our agencies now need to do with all these different parties has just exploded in the last few years, even the last 6 months, I would say. And so it's just going to be really important to maintain these dialogues and know what's coming up front, and then also be able to work with each other to be able to shape what the future of these observing systems are, ultimately to be able to serve our missions.
Thank you both, and thank you for the question. We do have a question from online that I want to make sure we don't ignore. So I was going to ask, as leaders, how do you recommend early career professionals balance specific expertise and breadth and generalist skills? Either one of you.
That's a great question, and I think it's not one we can answer for everyone because it depends a lot on your interests and where you want to go. And so I think that there is depending on what kind of world you want to be in and what you want to do. I started my career, I have a math, computer science, and engineering background, and I started my career doing modeling and writing code. And I really, I have a lot of depth of knowledge of models because I spent a decade writing code for them, and it was really valuable. But it's also really valuable, when you come to settings like this, that you'll get asked questions more about the Earth as a whole. And I think it depends a little bit on the person and what their interests are on that. But there is, probably every role includes a little bit of both, a little bit of breadth and a little bit of depth.
Yeah, my advice to early careers is always to build new skills with every job or opportunity that you have. Because if you just do one thing, you can only do one thing, and that will be your career for the rest of your life. And for some people, that's what they want to do. And you should do that if that's what you want. But if you want to have these dynamic careers where you move around, you do many different things like we have, you need to build these different skill sets. And then those skill sets are building blocks that you build upon to then find your future career. And I don't know about you, I didn't think I would be necessarily in this chair as someone goes between finance and entrepreneurship and climate science. It was something that other people hadn't done before. And so it was my mix of skills and depth, but also my ability to communicate and broad understanding, which allowed me to be where I am now.
Yeah, I think that's an important point. You don't necessarily have to know where you'll be in the far future. I certainly didn't know I would be here. When I left high school, all I knew was I liked math. I didn't really have a plan. I also liked space and liked being outside, and that has turned into the job I'm in now, which I didn't actually know could all be in the same place before, but they are now.
Thank you both. It really is inspiring, and you both light up with such energy when you talk about that. And so I think that's really great advice for early career to think about. Don't be afraid to try new things and try to learn something in every opportunity and look for those opportunities. So fantastic question from online. Thank you so much. And I see we have more questions in the room. Yes, go ahead.
Yes, hi, I'm Kurt Hamill. I'm retired U.S. Navy, but currently with Esri. I appreciate the organizers of the conference for putting on this fabulous, fascinating series of days, very useful for us and for this panel. It's very interesting. I have a whole of government question, really. I know you spoke about the camera and how that's an interagency hub bringing data together. And I'm just curious about other interagency efforts to change the conversation around climate. I think everyone at this conference certainly understands the climate is changing, and all of us are doing something about it. That's not necessarily true about all of the United States. There's a large fraction that still are in that, is it really happening? So is there an interagency effort to perhaps change the conversation from is it happening to how we're going to make things better? You mentioned climate or resilience.climate.gov. What other ideas would our premier science agencies have about changing the conversation around climate?
Yeah, we've been trying to work through the interagency groups to bring all the knowledge into single locations, because I think a lot of it was compartmentalized in pieces. So camera, for example, is bringing in everything to be able to understand exposure across all of climate. But then we also launched this summer heat.gov. Heat is actually the #1 killer in the United States. Most people aren't aware of that. And so that was, again, bringing in CDC, Health and Human Services, our observing networks, our information around heat to try and help people. And through communication, on your point of understanding broadly, I find that people's relationship to their local climate tends to be what evolves their thinking in time. And so with some people, it's a discussion around the fish that they like to fish are changing. They're not there anymore. What is happening? Why is that happening? Is that what climate change is? Or a recent conversation I had with someone in North Florida around the extreme rainfall that happened during Ian. Like, the storm hit on the other side of the state, but there was extreme flooding over here. I'm like, yes, with climate change, we have more intense rainfall in storms. That is one of the biggest signatures that we have, is our understanding of climate change and hurricanes. And so there are these aha moments that people have, but it's also really localized. And so that is part of a lot of the efforts around some of these new tools for exploration, but also the communications around it that need to take place is making it localized for people so they understand. And particularly on heat, because it is a rising risk that people haven't experienced before. We have heat.gov, but we're also building out citizen science around heat as well, that in cities around the country, we're getting citizen scientists involved to be able to go take measurements on we do this on the weekends. We give people thermometers and other instrumentation. They drive around the cities and they see what is the difference in heat at the urban scale, at a very high scale in the city. And then that information comes together to understand, okay, in a heat wave, how does that amplify in that city? And then what does that mean for the urban planning? And we're doing this across the entire United States. And actually, there's a call right now to sign up for the next set of cities for 2023 to be chosen. And we're finding that this is having a lot of engagement with cities around their climate exposure and risk, because heat is something that many of them haven't experienced in a way that has worried them to this point until recently, and so they're trying to build out what are their plans going to be and how they're going to deal with it going forward.
Yeah, and just to build on that, I think a lot of the interagency conversations are around local and people and making sure people have information that they need as they're going forward, both about how the climate is changing where they live, how it might change, what we know about climate in general, and trying to bring that. And so there's a lot of conversations around that and thinking about local. And I would just also say in this, I think this is where each agency, not only do we have complementary information in science, we also have complementary partnerships. We each reach a different set of people depending on where we are, where our centers are, how we're structured, and so we can use that to learn more about the local communities and to communicate more and make sure people have information when they need it.
Yeah, and to add to that, I think we're also moving from a phase of just providing information, because the information has no value if people don't get it or access it, to figuring out what are the plans in those local communities for engagement so they can actually make that information actionable. And I think that's also a shift for the entire climate community around just reporting on what we're seeing, reporting on what we expect, to saying, okay, what does this mean and how are you going to deal with it? And I think the awareness across all of commerce, across all of different sectors, across the economy now on realizing that they have to start dealing with this or thinking about this or understanding the exposure is also driving businesses to demand this and to try and do it together. So it's happening at the community levels, it's happening in the business level, we're happening at the federal level, and we're trying to have those conversations everywhere now.
Terrific, thank you. I see we have another question in the room. Go ahead.
I think you teed up my next question quite well, actually. I'm Jess Whitehead. I'm the Executive Director for the Institute for Coastal Adaptation and Resilience at Old Dominion University up the road in Norfolk. But I come to this position from a long career of working with local governments at the state and local level on climate resilience planning, including, thank you for mentioning Sea Grant, as the first coastal climate extension specialist within the Sea Grant network all the way back in 2008. So was wondering if you could speak a little bit more about that new focus now and shift to not just thinking about the information, because it's not plugging an information deficit model for getting this kind of action, that information to action, because the word to does a lot there. There are so many communities that are not even to the point where they can go to resilience.noaa.gov or heat.gov and look at that information and understand what they need to do to be able to scope off an RFP to capture funds that are coming out of programs out of IIJA or IRA, or to capture a FEMA BRIC grant, to understand how can I use my disaster funds that I'm getting from HMGP or CDBG-DR to be able to do resilient projects that help me act on that information. There's a translational piece there that's involved, and the Sea Grant Network is one amazing resource, but we're still talking about maybe, if we're lucky, a handful of people per coastal state. So what now is the game plan for the federal government to be working on building that capacity element, and what are the role of the universities and the private sector in that space?
Thank you for the question. Sarah, would you like to start?
Yeah. We need to expand our capabilities in that space, and we're really excited about the funding that we got for IRA, particularly for coastal resilience, to be able to expand on all the activities that we're doing. And with a comment that you touched on, something I forgot to say earlier is that, everyone here probably has a technical background of some sort. We're all extremely logical. We're all very aware of what's happening with climate change in our coastal communities and with the ocean. But when you go into communities and they're making complex decisions of, what do I need to do for climate resilience or sea level rise? What do I need to do for my unhoused populations? I have people that are unemployed. I have people with substance abuse, or I have this. And you go through all the problems that people face. Climate is sometimes one of the pieces, but it's something that's pushed off. And so something we've learned through our engagement through Sea Grant, but also through our cooperative institutes with universities and the communities and NOAA dollars, as well as some of the other engagements, is that we need to help make these overall resiliency plans. And our social scientists have been exploring how when you build those overall resiliency plans where climate is one of many things, it helps people make better decisions, because then they're not just putting climate off for the long-term decision and dealing with the ones in their face at the moment, but then they can integrate those decisions. So like an example is a community that had crumbling housing infrastructure and they needed to build more housing. And so they just wanted to patch up what they had that was along the coast that would be at risk 20 years from now. And so that investment today would be worthless 20 years from now if they did it the way that they were originally going to do it, because they were just going to patch it up, be done with it. But spending a little bit more money, building that elsewhere, moving the people, ends up being the smarter decision long term, holistically, when you're thinking about the climate issue plus the housing issue that they had. And so these integrated decision making across different decisions with climate as part of it is really important, and it needs to happen with within our communities and with the help of how to do all of those decisions simultaneously. And I think that that will be a growing need that we see, and there's some work that we did and funding that we put into that through the BIL law was going into these communities, particularly Justice 40 communities, to help with that type of decision making.
Yeah, I would just say in general what I'm seeing throughout the U.S. government is this more of a, we're all thinking about how can we help and asking people what they need. So it's not just about putting data on a website, but actually asking the people that use that data, what are you doing with it and what can we do to make it easier? And I think we each do that in different ways. For us, sometimes our users are other federal agencies, so talking to NOAA about what do they need and having those conversations so that we make sure, and that's led to some of the things that I mentioned earlier about, cloud compatible formats or training on data in Spanish languages, what do people need? And I think that, we're seeing that throughout and we're sharing information, and I think that will help communities.
Yeah, I should also say that we're also pushing for our weather forecast to be more in Spanish as well and new capabilities. And it's through the feedback that our agencies actually get separately and then discussions that we see very similar challenges in the communities and that we realize that we need to push forward on making some changes to be able to improve accessibility.
I love it. I think accessibility is such an important component when we think about climate change and we think about the future of our oceans. So we have another question in the room to the rear microphone.
Hi, I'm Adrienne Lai. I'm an undergraduate researcher with MIT Sea Grant Laboratory. I'm actually from Virginia, and in high school I participated in the Virginia Space Grant Consortium programs, and I learned a lot about NASA's Wallops Islands and the Earth-based platforms there, like scientific balloons and sounding rockets. And so we've heard a lot about satellites and sort of modeling for future ocean observing, and I was just wondering how the Earth-based platforms sort of fit into the future of ocean observing, I guess.
So we use a variety of different platforms depending on, what we're trying to learn. And I'll just mention one, not really an airborne and sea campaign that we did recently. It was a 5-year campaign that ended about a year ago called Oceans Melting Greenland, or OMG. And it was trying to understand ice melt of the Greenland ice sheet. And so what we did is we flew planes over the edges and we dropped other measurement tools underneath, and we could try to understand how much was warming from above versus warming from below contributing to ice melt. And so we do things like that where we try to pair, process understanding or high resolution information from these other types of observing platforms, whether they're airborne or balloons or ground-based, and then we can use those in combination with satellites to provide a more complete picture. And I know NOAA has a lot of these ground-based measurements as well.
Yeah, and I would say something I forgot to mention earlier is we have many different types of models and hierarchies of models to be able to get at different problems. So we talked about the projections and long-term projections on the global scale from our global models, but then we have regional coastal models or tidal models that allow us to get to those specific regions and are at a different scale, which can use information from those long-term models to be able to force them and be able to look then at the local scale. But so we have these different types of models to be able to approach different types of problems. And as those models evolve, they do recombine and combine together, but also sometimes we need to keep them separate and their development separate. And it's all part of a model ecosystem for us to be able to observe, understand, predict, project what the future holds.
Thank you.
Fantastic, thank you. I did want to talk about this just a little bit because the focus of the Oceans 22 meeting, it brings together so many different sectors, public, private, nonprofit, foundations. I'd really like to hear each of your thoughts on, are there specific areas in ocean observation that you foresee a lot of growth and potential for partnership opportunities? And if so, what is needed in order to foster growth in those areas when it comes to the role of the federal government? I know each of you have touched on this a little bit already, but in light of the context of this meeting, I'd really love to hear your thoughts. Sarah, would you care to start?
I think there's some exciting things that will happen in the future around building out more hardware and deployment of observing systems that may come from foundations in the private sector and innovating there. And through discussions with some ocean-focused foundations, there's a lot of appetite and desire to help advance that, particularly on the really riskier technologies that are starting to emerge and figuring out how to use them. But then also from some of the foundations, particularly ones that have funding from a very technological or Silicon Valley basis, there's also a lot of interest in the role of AI and the future of AI and machine learning and use for bringing in all these data streams. And so we're finding that experts in different fields that are then associated with some of these foundations or even in the private sector are wanting to partner to help bring their unique expertise that we don't necessarily have at NOAA to help build partnerships. And so we're signing MOUs or CRADAs with these groups to try and create joint products or try and do joint data sharing to figure out what is the future of this process or understanding or delivery of some new product, and working with these groups, which that has happened a little bit in the past, but I'm seeing right now an explosion in this and the interest, and we're trying to figure out our strategies around that, how to do that, how to do it effectively. But I see it as the future of being able to do a lot of the work that we need to do, is being able to incorporate all these different groups.
I think that when I think about partnerships, it's really about leveraging complementary skills. And so we talked a little bit about the commercial small sat data acquisition. You know, those are, for us to buy that data is pretty low cost, and you can get, you know, a lot of information in that way. And so there's a lot of value add in doing that. And if we do engage, you know, we have interagency partnerships to complementary skills there. We have commercial partnerships. The thing we haven't mentioned yet is international partnerships, and that's something that we do a lot of. So a lot of our ocean observing systems are in partnership with European. So, you know, Sea Level Rise, we have some European partners. We have a satellite mission launching in December that's going to observe the ocean and better understand ocean dynamics. That's in partnership with the French Space Agency, with contributions from the UK and Canada. And so working together with those, and we each bring something different to the table. And we can advance the science that way by combining that in a complementary way.
Yeah, and I'll add to that on the international side with seafloor mapping, with our uncrewed systems. We need to partner with these different countries and scientists around the world to be able to attack these different types of problems and make sure that we have that observing network and that we can share the data. But then also, if we have a float out there, that someone can pick it up or someone can help us with the deployment of it, because we can't deploy everything everywhere around the world all the time. And these partnerships have been growing, and it's been really exciting on particularly the ocean, which is global. You need to have those partnerships for building our understanding and our preserving systems in the future of it, because without that, we'll only be looking at, you know, what's off our coasts, which will not give us the full picture of the world.
Thank you both. And we are nearing the top of the hour, but of course, with a panel like this, I want to give you both a chance to speak to the future. And so what observing system technologies and monitoring capabilities do we need to understand and assess climate and ocean ecosystem change? How do regional efforts translate to future observations? And what does the future of ocean remote sensing hold?
I mean, I can start with that. I mean, I think some of the big questions in oceans are around like how much carbon and heat oceans absorb. And I mentioned this earlier, you know, this is where a large fraction of the heat goes. This is where some of the carbon that goes when we emit carbon, some of that goes into the atmosphere, some's on land, and some is in the ocean. And how much the ocean can absorb depends on how much it's circulating, depends on the biology in there. And so we have some satellite missions coming up targeting both. I just mentioned SWOT, the Surface Water and Ocean Topography, launching in December. That'll give us a better understanding of ocean dynamics. PACE, that's coming in 2024, will be more on ocean color and give us more information around phytoplankton, which have a role in the carbon cycle. And so trying to understand those so that we understand, you know, what's happening in the ocean now and how might that change in the future.
Yeah, and on that heat content, it's one of the most critical ones for us for understanding our fisheries and the current fisheries, what happens in the fisheries and what is going to happen in the future, but also for our forecasting of hurricanes. And post the major 2020 season of hurricanes, there's been a lot of effort of thinking of how are we going to better understand heat content in deeper layers of the ocean to be able to understand our intensity and also our tracks. And this goes back to the data assimilation question that came up of we need better information in the deep layers of the ocean, and that improves our hurricane forecasts. And so how do we get that data? How do we bring it in? How do we data assimilate it into our forecast systems, into also our seasonal prediction models for our seasonal prediction models of the future of Atlantic hurricane season, so we can know in advance and have ideas about the numbers of storms that we're going to have, and even advance that to maybe where they may be regionally, not just basin-wide. So advancing our understanding of ocean heat content at all layers is really critical for advancing these different pieces, and will be also more important with fisheries as well, as we try to predict those marine heat waves, where they're happening, and then what are their effects going to be.
Great, thank you. I appreciate the emphasis on not just looking at these surface oceans or these superficial changes we're seeing just in one dimension, but thinking about how to extend that to the depth of the ocean. That's one part that, at least with a NASA background, has always been tricky to try to get at that. And so I appreciate the fact that NOAA is working in this space. NASA has exciting upcoming missions that are going to be helping touch on these things. I did want to make sure we touched on futures. However, I think we have a couple more minutes. If there's one last question from the audience that somebody would like to ask.
Thank
Go
you so much. My name's Jan Newton. I'm an oceanographer at the University of Washington and also the director of NANUS, one of the regional associations of U.S. IUS. I also am involved with a project, a National Science Foundation project called Backyard Buoys, and it is trying to get wave data into the hands of indigenous communities and doing it through some leveraging the strong relationships with tribal communities and other indigenous communities that the regional associations have had for the last 20 years, and then hoping to sustain that. So I'm really interested in hearing your thoughts on other programs that might be focused on tribal or indigenous communities and how to really leverage our relationships and making a difference. So curious for your thoughts. Thank you so much.
So through our regional climate centers that used to be called RISAs and now is called CAPS, we have those engagement with getting the data and then working with the different groups. With Sea Grant as well, there's a lot of engagement trying to engage directly with tribal communities around data collection, but also data use and planning and resiliency planning. And also through our coastal program, we also have engagements around what are the risks, what do we observe, and how to plan and deal with those issues after they happen. And I think also through heat.gov, there's been a lot increase in engagement and planning around the exposure of heat and future of heat to be able to engage. And I think that these programs are very much a focus of this administration. We're seeing it across all federal agencies of creating plans and having our policy experts working on this problem to try and improve engagement.
Yeah, and I think in general, we try to engage lots of different types of communities, all ages, all backgrounds, all geographies, and there's different ways that we can do that depending on the needs and the capabilities. So we have a science engagement and activation team, we have a lot of citizen science programs, and they each serve a different purpose, but our goal is really to reach as many people as possible in the manner that they understand. So not everyone learns in the same way, not everyone processes information in the same way. So trying multiple platforms and multiple outreach activities.
Yeah, I'll add that through our, there will be, there's grants within that open for also the funding for this that we do through the Climate Program Office, particularly on the social science side, but also on the community engagement side within that to be able to provide the money to be able to figure out how to make use of the data that we have or how to create it into action for building out these types of resiliency plans or even the social science of how are people using that information or not using that information and why. So then we can understand that to then build our future products and services to make sure we're accessing as many people as possible.
Thank you again for that question. I think it's really important as we look to the future and as we conclude this hour's discussions to think about how to make things more accessible and how to reach an inclusive set of an audience. So thank you again for that question. And thank you both for your answers. Before we conclude, I'd like to invite Laura Rogers back up on stage just to wrap things up.
Thank you, Joel, and please join me in thanking our panelists, Kate and Sarah. This is a fantastic Oceanside chat. So. All right, and that was a fantastic segue to our next panel. We've really hit a lot on partnerships.
...2022 oceans of what the three federal agencies, Navy, NASA, and NOAA, have brought to the conversation this week. I have been absolutely floored by all of their participation, their comments, their engagement. And I can't thank you enough, federal agencies, for how you've steered our conference to the theme of Resilient Coast, adapting today to secure tomorrow. So for today's focus, as we've talked about partnerships and whole of government for the week, today we're really focusing on how do we secure tomorrow together? How do we secure for not only today's children, but our grandchildren? What do the future generations, how can this all play out? So for this morning's final plenary panel, I am absolutely honored and thrilled to introduce to you Tim Gallaudet, who will moderate. Tim and I both served in the United States Navy, and I was surprised, Tim, when I read your bio that you and I were 30-plus years on active duty. I didn't realize that. He and I both served in the Navy for 30-plus years. We were in a community where we were tasked by the United States Navy to understand the environment, meteorology and oceanography, from the top of the atmosphere to the bottom of the ocean. So it was quite a thrill to work with the Trident submarines for me, for driving U.S. Nimitz-class carriers, being involved in the Gulf War, and how the meteorology and oceanography applied. Well, Tim made it all the way to the top. He made admiralship and did a phenomenal job leading our officers, our sailors, our Navy civilians to make better use of science, earth science, if you will, as a force multiplier. Tim went on from the Navy and became the head of NOAA. And now he's doing wonderful consulting and continues his career. His passion for the sciences is as much as mine. And I know he graduated with a PhD from Scripps. And so, Tim, I'm telling you, I salute you, sir. Thank you. Come on up.
Thank you, Captain Toll. It's great to be here, and I appreciate that very gracious introduction. It's also great to be here with my Scripps classmate and office mate, Dan Sternlicht, Dr. Dan Sternlicht, with the U.S. Navy, and a lot of former partners and peers. So thanks, everybody. And it's nice to be kind of closing out this Oceans Week here to talk about partnerships. So to begin and introduce this panel, I want to start by sharing with you a recently published book. And this book is called Lethal Tides, Mary Sears and the Marine Scientists Who Helped Win World War II. And it's by Dr. Kate Musumeci. And interestingly, she's a medical doctor, didn't really know anything about oceanography, but her father was a quartermaster in the Navy and had served on many of the amphibious landings in the Pacific War. And so she kind of learned about that and became interested. And here she goes and writes about Mary Sears. And I'm really honored to be in a position to have basically been carrying out Mary Sears' legacy, because she was the first uniformed naval oceanographer, working at the U.S. Hydrographic Office in Suitland, Maryland. And it's a really terrific book because, for a number of reasons, but one is this small team of hers in the Hydrographic Office did the first oceanographic studies to support the Navy, and it was a huge endeavor when you think about all the information the Navy needed: currents, tides, sea state, beach slope, even sonar propagation conditions. All of this information was provided by this small team under Mary Sears to help the largest Navy ever assembled fight a global two-ocean war. And they pulled it off extremely well. And what's even more remarkable is they did it without any of the modern technologies that we're talking about most of this week, like buoys and gliders and uncrewed systems and satellites, digital data, artificial intelligence, machine learning. All of that was not available to these incredibly hardworking and insightful oceanographers. And they did it. But they also did it without iPhones. Can you believe that? Or PowerPoint. So what's interesting, though, is that we do still share a common characteristic, and that is a dependence upon partnerships. And like we do today, they did in a great way back in World War II, working with numerous government agencies. For example, that small Navy office that became what was now the Naval Oceanographic Office had a very tight relationship with NOAA's predecessor, the Office of Coast Survey. And there's great stories in the book about it. The international partnerships that we kind of closed on in the last session were really important because many of the international oceanography institutions had all the data we needed. I mean, interestingly, we even gathered reports from Japan when we were prosecuting a war against them that they had published and were in the Library of Congress. So international partnerships were important and are important today. And so take this this book home with you in your mind and buy a copy if you will. I actually have a podcast on the American blue economy. In the last episode, I interviewed Kate, and it was a lot of fun. As we look forward now and into the ocean in the mid part of the 21st century, I think we're going to see that partnerships will be critical in a number of areas. Coastal resilience, as is a theme here today, but also going bigger, the larger blue economy. And in addition, national security and natural security or conservation. All of these can advance in our oceans through partnerships. And so we're going to explore that today. And this really superstar panel I have are really well equipped to look at all the aspects of partnerships in these areas relating to the ocean. And first off, though, I'd like to I'll bring each one up on stage, ask them to take a seat. I'll announce their title, and then I'll go through and as we each gives a little talk about their topic, I'll read a more full biography. So first off, we have Jeffrey Moss. He is the Director for Warfare Requirements at the Commander of Submarine Forces, representing the Operational Navy. Jeffrey, come on up. Nice having you here.
Thank you. Pleasure to be here. Where would you like me?
Wherever you'd like to be.
All right. Very good.
Okay.
I'll squeeze by here.
And then we have Miss Emily Medina. She is the Mine Warfare and Ocean Engineering Lead at the Office of Naval Research, representing the Navy's mighty R&D enterprise. Come on up, Emily. Nice having you here.
Thank you.
All right. Next on the docket is Miss Laura Trillis. She is the Senior Program Director at Linker, NOAA's top contractor and the nation's premier environmental services company. Laura, come on up. There you are. And then we have Cheyenne Huck. He is the North American Business Development Manager at XBlue, which is a producer of leading-edge navigation and marine autonomy solutions. Come on up, Cheyenne. And then, kind of rounding it all out, is Dan Stillman. Dan is the Director of Marketing for Government and Space at the company Tomorrow.io, the world's best-in-class commercial weather company. Come on up, Dan. All right. First up is going to be Jeffrey Moss. Jeffrey is a native of Northampton, Massachusetts, and he is a two-time graduate of the University of Massachusetts at Amherst. He received his bachelor's degree and master's degree in mechanical engineering, and he is also an alumnus of the Naval Postgraduate School, where he studied underwater acoustics, near and dear to my heart. And during his academic tenure, he has generated over a dozen peer-reviewed articles, as well as has been granted several patent rights. In the public sector, he has worked at the Naval Undersea Warfare Center and the Naval Research Laboratory. Mr. Moss served on both the Submarine Force Pacific Fleet and Atlantic Fleet staffs, most recently as the Office of Naval Research Science Advisor to Commander Submarine Forces. That was his recent tour. And then now, in his present assignment, he directs the development and assessment of requirements for platforms, payloads, sensors, weapons, infrastructure, and the laydown of conventional and strategic U.S. submarine forces. A big partner of mine previously when I was the head of naval oceanography. So, Jeff, the floor is yours.
All right. right. Thank you, Admiral. Let's see, everybody hear me? Well, thank you for the introduction, kind words. As the Admiral said, I am the Director for Requirements for the Submarine Force in the Atlantic. In that role, Submarine Forces Atlantic is responsible for organizing, training, equipping, and certifying submarines for worldwide operations. So the big thing on our minds and primary focus of my attention these days is continued strategic deterrence. The Trident submarines that Ray mentioned evolved into the Ohio, and we are going through a once-in-a-generation similar change from the Ohio class to the Columbia class. I'm sure you've seen in the news all of the bullets on how challenging that is, how complex that system is. At the same time that we're going through the submarine platform itself changing, we're also recapitalizing the weapons systems that go on board. So very precise, very detailed, lots of physics, lots of complicated problems, all at the same time. As it pertains to climates and oceans and partnerships, at the same time we're doing that, we're also recapitalizing the waterfront. So the piers, the pilings, the power, all of the hotel services that support the actual home porting of the submarines. It's not as simple as saying just replace old with whatever the latest and greatest is. You know, as the Admiral states, now we've got iPhones, we've got all of these new technologies to contend with, and we understand more about what we need to prepare for. And so in setting requirements for all of the stuff that I just mentioned, understanding, measuring, and projecting the climate is critical. The other thing that's sort of changed, we talked about some of the historical benefits and projections, and we've talked through other major conflicts. The nature of strategic deterrence has changed. So we are now in a multi-axial, multi-simultaneous type of strategic deterrence. So I know we have a lot of people with the scientific backgrounds. Just quick show of hands. How many people have taken Calc 1? Okay, perfect. How many people then took vector calculus, Calc 3? How many people thought that was easier? Okay, so we're in the right place. People are doing the research like that. That's why I'm up here. That's arguably not a fair analogy because at least with calculus, everybody agrees on the rules. And that's just not the case today. So we're in a position where we have to deter multiple peer competitors in different ways. It just makes it harder. The discussion at the previous panel on budgets and appropriations is very appropriate to my line of work. So we go through all of the pieces of government to get funds, and we do have large budgets, but I'm sure you've seen in the news or if you've experienced going out in the world today, inflation is a real thing. So yes, there are large dollar values, but the actual buying power of that dollar is being suppressed. What that means is we're going to see a contraction in some of the things that we buy. Also because of choices that were made a long time ago and just the rate at which we can produce things, we, the submarine force, are seeing a drawdown in the force. You know, fewer submarines available to meet the increasing demands. What that means is there's higher ask of the sailors, higher ask of the waterfront, higher ask of the technologies that support them. What that means for ocean sensing, as you've probably experienced in your own lives, if you have fewer of anything, the precision or the authorities that you have to abide by are more sharply enhanced. What that means is we need more accountability. We have to be more precise, more accurate, better understand, make better use, make optimal use of the limited number of things that we have. I think that highlights for this community the importance of understanding the bathymetry, the currents, the waves, the weather, all of those eaches so we can lay down and operate as efficiently as we possibly can. There are cases where we get this right. The Admiral mentioned some of the predictions influencing the way we operated. There are cases where we don't get it right. I'm sure you've seen some of the news clippings on groundings. It's important to understand what's out there because submarining is hard. It's especially hard in areas where you don't have as good fidelity on the data of the bathymetry you're operating in. The use of uncrewed systems that we talked about is especially important. So going and surveying an area is not a particularly great use of what's about a $3 billion asset. However, it's a great thing for uncrewed vehicles to do. Uncrewed vehicles are wonderful at doing the dull, dirty, dangerous, or otherwise impossible things that we can't ask of the crewed submarine force to go do. However, we still have lots of research, open questions in autonomy, the navigation accuracy, so thrilled to hear about some of the latest advances there. The partnerships with NASA and NOAA are particularly poignant. Even though the physics are different, there's a lot of common engineering problems. So high latency, denied or degrade communications means you can't just hit a button and see how it's going. So planning, understanding the environment, projecting, and developing the runtime is critical. Lots of parallels there. And so the challenges in that specific technology are not unique to us. We have interests in power and energy, but that's common to a number of other areas. The submarine Navy is a little unique in that we are entirely nuclear powered. So the local energy source aboard a submarine is pretty secure. We understand very exquisitely how those reactors work, their lifespans, their power, energy outputs, all that. But again, back to so they have to live somewhere. Once they come back to port, we have the same interest in secured, assured power that many other sectors do. I say all of this in the ultimate goal that I led off with is strategic deterrence. So what we would like to see is rules-based international cooperation, collaboration. Again, it's competitive, so we like competition. Competition drives innovation, but we'd like to see that in a rules-based sort of structure. I say competition not because of just the operations at sea, but because there's competition everywhere. There's competition for natural resources, there's competition for talent, there's competition for insight, there's competition for innovation, and we'd like to see all of those proceed in accordance with a rules-based structure. Excuse me. The nature of that competition, like I said, has changed, and it's now multidimensional. But I want to highlight that doesn't necessarily mean conflict. And I think conferences like Oceans are critical to building the alliances and partnerships so that there can be fair, open competition without conflict. In my line of work in the Department of Defense, the chain of command, and I'm sure the Admiral and Ray can speak to this, give you pretty clear direction. There's orders and authorities and expectations. The chain of command will tell me how to operate and how to do my job and how to engage up. Engaging out, though, is sort of an open area and one that we're interested in. And again, I think conferences like this are wonderful forums to do that. There's always an interest in defense and military operations. They're fascinating. It's part of the reason I like coming to work. I can't go into the specifics on how that all works, but in the framework of security, there was a recently released national security strategy that's pretty clear on how this is all supposed to work. I'm going to read a quote to you so I don't go from memory here. The United States vision is for a world that is free, open, prosperous, and secure. Our alliances and partnerships around the world are our most important strategic asset and an indispensable element contributing to international peace and stability. We place a premium on growing the connective tissue, technology, trade, and security between our democratic allies and partners in Indo-Pacific and Europe because we recognize that they are mutually reinforcing and the fates of the two regions are intertwined. It's pretty compelling, pretty clear that we need partnerships and alliances and to continue the dialogue. I'll leave you with one more. While we have profound differences with the Chinese Communist Party and the Chinese government, those differences are between governments and systems, not between our people. Ties of family and friendship continue to connect the American and Chinese people. And so with that, I will thank everybody for being here, for their participation this week. I thank you all for your continued pursuit of science, discovery, collaboration, and forums like this to share ideas, if not ideals. Thanks again to the organizer, and specifically Admiral, for your sharing this. This is great. I look forward to your questions. Sir, over to you.
All right, well done, Jeff. Thank you so much. And the submarine forces of our Navy operate in all the oceans of the world and really can do anything in those oceans. So a very capable force, and thank you for your national security perspective. Now I'd like to introduce Emily Medina. Again, she's the Mine Warfare and Ocean Engineering Team Lead at the Office of Naval Research. Her responsibilities at ONR include strategic oversight and direction, constructive development and resource planning and management of the Mine and Expeditionary Advanced Technology Program for the Navy, which includes science and technology research for mine warfare, naval special warfare, that's Navy SEALs, I had a tour with them, and explosive ordnance disposal, as well as the Marine Corps communities. Ms. Medina also serves as a program officer for the mining S&T portfolio, a multidisciplinary investment area, which includes machine learning, autonomy, and sensor and communication systems for the underwater domain. Previously, Ms. Medina served as staff science advisor for 5 commanders of the Naval Mine and Anti-Submarine Warfare Command. She holds a Bachelor of Science degree from San Diego State University and a joint master's degree from the University of California, San Diego, and San Diego State. So we're fellow alumni of UCSD. And her awards include a Meritorious Civilian Service Award, which is quite an accomplishment. And she also holds over 20 publications, as well as 2 patents, another patent awardee, and in her field of gesture and language recognition and human-computer interfaces. Emily, the floor is yours.
Thank you very much, Admiral, and good morning to all of you. I'm very pleased to be here. I heard earlier this week that we were talking about oceans not having been in this forum for close to 10 years now. And I remember at the last Oceans I was here at this venue was actually when I was asked to come and join the Office of Naval Research. And the last, I think, 10 years, 8 to 10 years has been really incredible. I am here on the panel to represent resource sponsorship of the science and technical community for ocean systems. For those of you who, I hope everyone here is familiar with the Office of Naval Research, we are one of many organizations that serve our ocean community and foster research, not only for the defense of our nation, but in pursuing Navy-specific uses, utility, and needs for our shared community. The Office of Naval Research is an interesting organization, and among all of the services, handles science and technology investment in a very unique way. So we, in the Navy, when we pass the budget, all of our basic applied research and early prototyping monies are sent to the Office of Naval Research, and we have a very unique organization of about 120 different program officers that all represent different portfolios for our Admiral. Each of these portfolios have a wide swath of serving our communities and making sure that we are not only fostering the most cutting-edge research, but that we're growing the right scientists and engineers in our field. And so, as a representative of Code 32, the Ocean Battlespace Sensing Department at ONR, you heard from Dr. Drake at the keynote, and then earlier this week in a panel representing our interests within the Office of Naval Research and the different areas we fund. This is hugely important. I actually was very struck by the former panel when they were talking about this shared community and how we grow our communities and share both data but also experiences. It's multidisciplinary in a lot of ways, and even in a shared community, we all bring our own pieces. In a perfect world, each of the portfolios at ONR, and especially in Code 32, which serves our ocean communities, supports and leans on their research community to cull, curate, and defend the talent, both within our US performer base and globally, internationally. So there's a couple different ways in which ONR can do these things. Within Code 32 and our core programs itself, we do this through our enduring programs, looking at a number of different areas, both in uncrewed systems, but most importantly to the mine warfare and ocean engineering team, which I represent. It's really about the role of unmanned systems in attacking the different challenges that are complex for our environments, which are mostly the shallow water regions. These are very complex environmentally, they're dynamic. And our systems that we would maybe use for deep ocean or open ocean aren't going to work. Their persistence is not there. These are very congested areas with lots of different vessel activity. And so in order for us to really be able to provide gains in this, we need to be looking at some core issues, and human-machine teaming is one of those. So it's not just the uncrewed systems themselves and the sensors that they can bring to the fight. It's really understanding where the human and the machine work can overlap, not only in building operator trust, but in enhancing the ways in which an operator can either pull information down or react faster in a certain situation. So when we look at the ways in which globally we take those core programs that we're funding within just the US core programs and we reach those out, we have a number of different portfolios within Code 32 that work collaboratively together. So I represent an applied portfolio, mine warfare and ocean engineering. So we have some unique and hard thrusts in our areas that are driven by the missions that we do. And those are for every kind of operator, as the Admiral mentioned. This is Navy special warfare, explosive ordnance disposal, your mine warfare community, but also there's METOC, there's mobile mine assembly. There's lots of different people that do different tasks in that. However, when we look at our global partnerships, we have a huge role internationally. The mine warfare, I'm the US co-chair for our technical sharing programs. This is TTCP and TP13. And we have 4 knowledge thrust areas where we have US partners who are experts in their field looking at areas of sensors and understanding, of simulation and modeling, and being able to process and look at that data. And we share that across our partner nations. We use our core US programs to leverage and do shared experimentation with our partner nations. But beyond even our TTCP organizations and enduring investments, we have collaborations with, say, our physical oceanography portfolio that goes out internationally and does surveys throughout the world that work with international universities. And some of these surveys bring some of the best peer-reviewed and most cutting-edge understandings of the seabed and of the ocean in different parts of the world. So we have heavy partnerships with physical oceanography and with ocean acoustics in not only bringing up the right types of researchers in each of these areas, but creating those teams. That's the glue that a place like ONR gives to our communities. We create our teams. And we do that not only within the Navy's money, but we work within other agencies. So all of our partners, to include NSF, NOAA, DARPA even, if you're looking at the other, at OSD, and the other places there. So again, it's about serving the community. We're in a service role. the onus of our responsibility to the United States Navy is to basically incur risk. We're incurring risk, we're opening up competition, we're trying things that haven't been done before. And in doing so, we are able to inform the trade space to senior decision makers and say what really are the ways in which we recommend moving forward. And by our community going out and sharing and working together, we're learning those things ahead of time. So thank you again for your time this morning, and that closes my comments.
Well done there, Emily. Thank you. And I have to point out, as a 32-year veteran of the Navy, how I think overlooked our really bright and talented civilian force is. Look at these two incredibly accomplished individuals contributing so much to our naval readiness at a time where we really, really need it. So I want to thank you for your service, both of you. Okay, now moving on, we have Laura Trillis at the company Linker. Again, one of NOAA's top environmental contractors, and Laura is a certified project management professional with 16 years of experience leading teams, directing, coordinating, and managing projects, and delivering measurable results to clients. Laura began her role as a senior program director for NOAA's Office of Coastal Management, supported by Linker, in June of 2022. Previously, she served as Linker's business operations director for the Marine, Ocean, and Coastal Science and Information Group, West, based in Hawaii. She's experienced in managing a variety of client projects, taking in between 20 to 50 million in revenue, and overseeing groups more than 100 employees across multiple geographic regions, including those spanning 10 time zones. She leads teams of multidisciplinary program managers, project managers, coordinators, and technical staff working off-site, remotely, or at client facilities across the country. Laura is also classically trained as a coral reef ecologist, I love it, and an invertebrate larval biologist. She earned her graduate degree in marine science from Hawaii Pacific University, and she, very near and dear to my heart, is a PADI certified master and rescue diver. The floor is yours, Laura.
Thanks, Tim, and thanks for inviting me to participate in this panel today. Like Tim said, I work for a private company called Linker, so quite a bit different than our previous two panelists who work with the government, but I also work with the government, but from a private company side. And it's really been an honor for me to be able to share with you guys a little bit about my company. So my plan is to tell you a little bit about Linker and what we do, and then to tell you about the current project that I'm the program director for, and then a new and exciting chance for a bunch of partnerships that Linker has just been awarded. So, and I'll try to keep it fairly quick because I do want to allow time for questions. Maybe. Is it forwarding? No. This green button. Ah, there's two. So this is Linker's mission. We deliver innovative solutions to support global environmental security and economic prosperity as a trusted partner to governments, communities, and industry. And so a lot of people ask me, well, what does your company do? What does your company make? Well, the best way to describe that is that we are a science advising company. So we provide scientists and technical staff for a variety of different things, different projects. Just to give you guys kind of an idea of how geographically dispersed we are, this is a map that shows some of our office locations that are notated there in the darker blue, and then just the locations of all of our staff. And one of the things that always shows up really small on maps is the Hawaiian Island chain, but we do have a major presence in the Hawaiian Islands and then throughout the Pacific Islands and the US territories. And now, the company, I've been with the company for about 6 years. When I started, we only had about 40 staff, and now we have almost 500 staff. So it's quite, it's been quite an exciting ride for me to help grow the company over the past 6 years. I know this is really a lot of information on one slide, and I apologize for that, but Linker basically has 4 working groups, and I've always been a part of the first one there, the Marine, Ocean, and Coastal Science and Information Group. When I started, we were just a small little marine sciences division, but we've grown quite a bit in what our capabilities are and what we offer when we partner with different clients. We also have a water and environmental resources group, and we're very excited that we just started partnering with the National Center for Environmental Prediction and providing scientists and modeling professionals to that group at NOAA. We also have an emerging information technologies and system integrations group because, as has been pointing out multiple times throughout the week, this week, is how important new technologies are, especially being a scientist myself. There's tons and tons of data that we can gather and technologies that are making it easier to gather more and more data, but how do we assess the data and make decisions based on the data in a reduced amount of time when it makes the most difference? And then our newest division, the Earth and Atmospheric Sciences Group. So just a quick slide to show you guys some of the groups that we're partnering with. So we work a lot with federal clients. I would say our biggest client to date has been NOAA, the National Oceanic and Atmospheric Administration, and we work with all of their 3 major services, so National Ocean Service, National Marine Fisheries Service, and National Weather Service. And then some of the more recent clients include the Department of Education, the USDA, USGS, and the EPA. So the group that I currently manage is a support team of about 150 folks who help support the NOAA Office for Coastal Management. And our group is specifically focused on tying these 3 things together: communities, ecosystems, and the economy. And so, you know, I've heard a lot of speak about the blue economy and the new blue economy, and so we're definitely addressing that. And all of the work that we do for the Office for Coastal Management has to do with coastal resilience and making data and information available to public and private partners at the state level, at the community level, and then just it's also available to the public via websites and via trainings. So here's just a quick glimpse of some of the work that we're doing with the Office for Coastal Management. You know, we want to promote healthy coastal ecosystems, resilient coastal communities, and vibrant and sustainable coastal economies. And we have 4 main programs in partnership with NOAA's Office for Coastal Management that you see at the bottom of the slide there. And one of the ones that I'd love to highlight for you guys is just Digital Coast and the Digital Coast Academy, because this takes a large amount of data that's collected by different government agencies and puts it in a usable form and makes it available to the partners and to the public. And it also, as part of what we do, is we have instructional designers, instructional design technologists, trainers, and we take this information and we put it in a usable format and we provide trainings, whether it's digital or whether it's our teams coming out to state and local partners to teach them what you can use the data for and how to use the data to accomplish their goals or to come to the management decisions that they want to come to for the different priorities that they have. So some of the strategies that we partner with NOAA on, science and information applications, conservation and restoration. We leverage these investments through partnerships, again, at the state and local level. We also want to promote the next generation of coastal managers, and NOAA's Office for Coastal Management has a pretty good fellowship program, and so every year we take applications for the fellowship program, and we help mentor and guide those fellows along with federal staff at NOAA. And then, of course, getting the public involved and getting the information out to the public. This map it combines NOAA and the linker workforce that supports NOAA. And so throughout the 4 different programs that the Office for Coastal Management has. And so I just wanted to point out here, there's 400 plus coastal communities that we collect and support data and support training efforts through. And so pretty much everything that you can see here is touching a U.S. coastal area, and that includes the Great Lakes. And then lastly, I've been talking about NOAA, but Linker has recently been awarded a USDA grant for climate smart commodities. And this project is near and dear to my heart, and I actually helped write the proposal for this grant opportunity. And it is just a great example of bringing together a variety of partnerships. So this was brought to us. You know, when you think about the Hawaiian island chain, you can't really separate the land from the ocean because it's a very small amount of land that's completely surrounded by the ocean, so everything in the Hawaiian island chain is coastal. And in this case, looking at how we can take some of the agriculture that happens out in the islands and start initiating and implementing climate smart practices as we move forward. And so, as you can see in the description, you know, it's going to help to overcome the climate smart implementation barriers. There's a lot of small groups, and I think this is true everywhere in the U.S., but particularly in a small island chain that's very remote. There's some really small groups who just don't have the capacity or the administrative ability to be able to pursue a grant like what comes out from USDA. And so in order to help them, being able to partner with a variety of these really small groups who have operating budgets of less than 6 figures, come together with the University of Hawaii, come together with a bigger corporation like Linker, and then we handle a lot of their administrative burden so that they can get out there and actually hit the ground and hit the fields and do the work that they need to get done so that we can move these processes forward and make sure that we have all of the mom and pop level agency or organizations doing it along with the bigger agencies. And so this has been one of the things that I'm the most proud of in my time at the Linker is growing the ability. We call it the Sustainable Pacific Program, where Linker as a big company operates as a big brother, big sister to smaller nonprofits and smaller organizations to band together and help them utilize government funding and initiatives from the government to implement changes as we look at sea level rise and climate change moving into the future. That's all I have, and again, thank you so much for including me in part of this panel.
Thank you, Laura. That was great. And if you haven't noticed, there's kind of a running theme. I was previously at the Navy, and then I served in NOAA, which I just love, and I really love working with Linker because they touch so many NOAA offices, so it's always nice to get back to my NOAA shipmates through Linker. And so Linker being a contractor, kind of like I pointed out the importance of civilians in the Navy, many of these, our federal government agencies really cannot operate without their large contractor forces. So you do a really important job, Laura, and thank you. But also, our government in the area of oceans and partnerships employs the private sector for goods and services, products, stuff, and information. And kind of along those lines, I want to introduce Cheyenne Hawk with IXBlue. Cheyenne is business development lead for IXBlue for the Northeast, or North America, pardon me. And he is leading their growth efforts in the area of U.S. offshore renewables, mostly for wind energy. And for the past several years, Cheyenne has been closely involved with the development of IXBlue's autonomous uncrewed vehicle, the DRIX. It's a remotely operated vehicle, and then he also has worked with some of the towed vehicles the company has, and that do geophysical and marine biomass sensing. And he's targeting primarily the wind farm projects, and they're working with companies like Ørsted. And he also is an area that's really important for these surveys are the fisheries applications. He has been closely collaborating with various oceanographic institutes and universities involved in ocean research and marine robotics, one of my favorites. And he's based in Boston and has been there for about 20 years, and he couldn't be happier to see the growth of the new blue economy and offshore renewables in the U.S. He is passionate about promoting solutions that are safe, reliable, and eco-friendly, and ones that help protect the many assets of the region, both natural and man-made. Cheyenne, over to you.
Thank you, Tim. Thank you, Tim, and thank you for inviting me to this panel today. Thank you, everyone, for coming. This is actually a very exciting topic for me to talk about. I'm with IXBlue, and as Tim mentioned, I'm based in Boston, and as a company, we we always value partnerships and collaborations with public entities, governments, even public and private collaborations. So this is a great panel to be participating in. And today I'll talk a little bit about who we are, what we do, and just give a few examples of different collaborations and partnerships that we have done over the years, mostly in the US, public, private, international, and then, but mainly I'll be talking about the collaboration that started with NOAA almost 5 years ago when Tim was still with NOAA, and not just with different entities within NOAA, so I'll speak about that. Yes, so just a quick word about who we are. iXblue, we're a French high-tech technology manufacturer. We're based in France. We develop advanced navigation, maritime autonomy, and photonics solutions. And so some of the different areas that we focus on, as you can see, we have got a lot of applications in the defense world, but also in the maritime autonomy. We develop solutions for subsea positioning, and we build the surface drone that Tim mentioned. It's called the DRIX. We also develop gyro compasses for space satellites, and also quantum gravimeters, as well as other photonic components. So as a company, we pride in ourselves in essentially owning the full vertical chain of production, from essentially the raw materials to the testing to the full solution, and having the engineering know-how to build all of that, which makes us a very versatile technology provider. These are just a couple of examples of some past private, public, academic partnerships. So we have a long-standing partnership with America's Cup, where we supply their the racing yachts with all our gyro compass solutions, and also our aerial inertial navigation system is used, as you can see in the picture, on the programmatic side, where they use some of that information for the augmented reality that we see on TV. So the partnership with NOAA collaboration started almost 5 years ago, around the same time when we launched our USV, the DRIX. And through that, we started an formal industrial partnership with the Joint Hydrographic Commission at the University of New Hampshire, CCOM. So it first started with some evaluations through collaboration with UNH. And last year, we delivered the first DRIX to NOAA OECI. Just a quick word about the DRIX. It's about an 8-meter long vessel made out of composite with Kevlar reinforcement, weighing at about 1.5 tons. So it's an open architecture platform, open to integrating any type of sensor payloads for positioning, seabed mapping, data communication, etc. And earlier this year, we delivered to NOAA OMAO the second of the USVs. And this one is a little bit different than the first one, because this one has both a hydro and a fisheries sensor package included in that, which is going to be used, our understanding, for NOAA OECS as well as for fisheries. And then as part of our ongoing industrial partnership with UNH, we have just in June opened a facility in New Hampshire. It's a center for excellence where we're ramping up production to be manufacturing DRIX in the US for all our clients. And it's also going to serve as a center where we train personnel to operate the DRIX, as well as to maintain, repair, and do all the support work for all the DRIX that we manufacture in the US. This is just, I just kind of took it from the press release that came out earlier this year. As I mentioned earlier, this is the DRIX that was delivered to NOAA OECI. OECI is the Ocean Exploration Cooperative Institute, including University of Southern Mississippi, University of New Hampshire, University of Rhode Island, and Ocean Exploration Trust. So in this mission that started in March, this was a joint effort where the DRIX was launched from and working collaboratively with the OET's RV Nautilus that you can see over here. And it has been involved in several different missions, teams from UNH with Dr. Larry Mayer and Dr. Bob Ballard's team from Ocean Exploration Trust were involved in several of those missions. One of them was the DRIX was acting as a communication relay for other subsea robotic vehicles. It was commanding and controlling the deepwater NUI vehicle, as well as the midwater Mesoboat AUV autonomously. And in another mission, it was doing seabed mapping, nearshore mapping of the coast in Hawaii. So this mission just ended. I believe there were 4 different missions as part of that. This is just a quick example of an international partnership and collaboration. This involved the governments of both Canada and France, as well as a multi-governmental agencies collaboration involving the Canadian Hydrographic Service, as well as the Ministries of Archaeology and Sea from France. This was a project that took place earlier this year in an area called Saint-Pierre and Miquelon. It's a territory of France, but it's in the western coast of Newfoundland in Canada. It's in northeast Canada. The mission was to map the seabed looking for a wreck of a fishing vessel that sank almost 60 years ago. And it had a terrible impact on the community because it's a fishing community, and there are still families whose predecessors passed away in that. So there's a big emotional tie to that, and the DRIX was used with multi-sensor form to basically map the seabed, as well as do some seabed characterization, trying to assess the sand erosion between the two islands. The cool thing about this project was that not only did it involve so many different entities from 2 different countries, as well as US, but this mission was conducted 24/7 over the horizon through remote satellite communication from our command and control center in France. So this is the first time we did that in international waters. We've also been involved with NOAA's New England Fisheries and Science Center for the last couple of years on a totally different technology that we have developed. This is a 3D multi-beam echo sounder solution for fisheries and biomass assessment. So last year we worked together with NEFSC in the Block Island Wind Farm, trying to characterize the biomass there. And we're now in discussions with them about the phase 2 of this project, which hopefully will be next year. This would be to integrate this sensor technology onto an unmanned platform like the DRIX and survey a future wind farm location in the Northeast. So we're in early discussions about that. And this is just a summary of examples of other collaborative projects and partnerships that we have done over the years, mostly around the USV solution. On the top left is what you see is the DRIX working as a force multiplier with NOAA's RV Thomas Jefferson. This was back in 2019. We have done other missions with SHAM, which is a French government agency doing a multi-DRIX mission where the DRIX was performing seabed mapping on either side of the mother vessel. Just one note about, I forgot to mention earlier, is the DRIX for the NOAA OMAO that was delivered early this year. There's already a mission planned for middle of next year, but this one is mostly for fisheries. And in that mission, we'll be working collaboratively with RV Oscar Dyson. So again, it just kind of shows the different partnerships that we have done over the years with different entities of NOAA. And I believe that was my last slide, so thank you.
That was great, Shan. Thank you. And I want to just point a couple things out here. I was with NOAA when DRIX was initially being tested. It was in the Chesapeake Bay that I was on the Thomas Jefferson. And just last month, the Thomas Jefferson did a pretty large survey in the Great Lakes with the DRIX operationally. So this is an R&D. This is a very, and now there's a couple other things to point out. Uncrewed systems kind of pervade this whole week, but multi-vehicle operations that was demonstrated off Hawaii with Bob Ballard's Ocean Exploration Trust, that's the way ahead. Swarms and groups of drones. The other one where NOAA's Office of Coast Survey is moving is ships becoming motherships for drones. That's where NOAA is moving, much faster than Navy, sorry. And, but that's really the future of technology in the ocean, and it's exciting to see. So Cheyenne, thank you. And interestingly, in the partnership theme, both Linker and IXBLU have gotten together to team on potentially providing more of the DRIC solution, because a gap for NOAA right now is the people. There's really no such thing as uncrewed systems, and getting a really competent workforce to help do the maintenance, training, moving the data, that's needed. And so we'll see where that goes. But it's kind of nice to see these partnerships evolving on stage. And lastly, and certainly not least, because when we talk about our oceans, we have to talk about the weather and climate, as the ocean's such a big driver of weather and climate. I want to introduce Dan Stillman. Dan is the Director of Marketing for Government and Space at Tomorrow.io. He is a meteorologist with a bachelor's degree of science from the University of Michigan and a Master of Science from Texas A&M. Previously, he led marketing for the Weather Satellite Division of L3Harris, and before that, he served in marketing roles with Planet IQ and Earth Networks. Dan is also a co-founder of the Washington Post Capital Weather Gang, where he has delivered the DC area weather forecast for the past 15 years on the Capital Weather Gang blog, and for the past 7 years on DC's local NPR station, WAMU, which I personally have enjoyed during my last 12 years of commuting into DC. And you do a great job, Dan, I have to say. Dan has published hundreds of articles in media outlets, including the Washington Post, CNN, and the BBC. Dan Stillman, take it away.
Thank you. Admiral, a pleasure to be here and part of this. Despite your introduction, I feel like I'm the least impressive of this very distinguished panel. But I do think I have hopefully a useful perspective related to partnerships. It's going to take me a few minutes to get around to it, but I promise I'm going to get there eventually. So I think, to sort of level set, we are here at a time where when I get to partnerships, the importance of them is in the context of this is a time of increasing intensity and frequency of extreme weather and the impacts, especially on coastal areas and marine environments. And so a fresh, and unfortunately a very fresh example of that is what you see on the screen, which is Hurricane Ian. And what you're seeing there is the tracks from 3 of the top weather models. And we've made incredible strides in forecasting in general and hurricanes in particular, in predicting their tracks and intensities. It's in some ways remarkable what we can do. And yet what you're seeing here with this particular storm was the lighter color tracks were the earlier forecasts, and the darker colors were the later forecasts, and there's a black line there sort of all the way to the right, which was the actual track. And so there was sort of a west bias, a westward error in the early tracks. And that, of course, led to some difficult decisions in the Tampa area and the Fort Myers area, Lee County, I'm sure if you've been following sort of the aftermath of the storm. And the problem is, despite all these strides that we've made in forecasting, the errors that still remain make it very difficult in some storms and some situations to make decisions on the ground. Whether that's evacuation, whether that's protecting assets, moving people, moving resources around. That can be civilian resources and assets, that can be military resources and assets, what have you. There's also an issue of communication and interpretation of forecasts. There's been a whole discussion after the storm of the cone of uncertainty. That's an important component as well, not really our focus and my focus today, but important nonetheless. So for forecasting, there are really 3 essential ingredients, and they are observations, models, and I would include with models computing capacity to run models. And more in recent years and going forward, machine learning. So these are the three main components. Traditionally, observations and modeling has been led by the public sector. The machine learning is an important component. Again, not really going to be my focus today, but an important component of improving our weather forecasts. But the observations and models are the core. And what we've seen over many decades is a steady improvement of weather forecasts due to steady improvements in observations and modeling and computing capacity. Steady but relatively slow. For example, the general forecast has improved by 1 day per decade, right? So 5-day forecast today is as good as a 4-day forecast a decade ago, and you can extrapolate that to different time frames. Same thing with, hurricane tracks. There's been a steady improvement, but it's slowed as we've gotten better. And the problem with that, the steady part is good, but the slow part is not good when you compare that with what we talked about at the beginning, this accelerating rate of the impact of the extreme events. So our ability to improve the forecast is not keeping up with the impacts that we're seeing of this increasingly extreme weather. So the next few slides are going to touch on, so there's two components, two questions, I would say, that are the focus here, at least of what I'm going to go through. And the first is, how can we maximize the forecast information that we have today? Right? So we have a certain level of accuracy today, and how can we maximize that? So this part, I'm actually going to kind of try to speed through it. This is the most self-serving part of the talk. This is where my company, Tomorrow.io, got its start, really. And that is in converting the weather forecast, your basic weather forecast, into operational weather intelligence. And you can see just a really simple example there. This sort of describes what our core competency is all about at Tomorrow.io. It's just one small example, but you have 60% chance of rain on a given day in a given region or a city. Boston is the example here. We're headquartered in Boston, actually, as well as IX Blue. I'm based in the DC area, but our company is headquartered in Boston. Versus, what is weather intelligence? It's converting that into something you can take action on. So the action here is, prepare for a road closure on these streets in this area on this approximate day and time, because the weather is going to exceed the threshold that's particular to that location or particular to your operations. So that's very different than just chance of rain on this day and time and location. It's really converting it to your protocols, your actions that you need to take. And so what we've done, again, still focusing on that first question, what can we do with the forecasts that we have today? And then I'm going to get beyond that soon. So our core competency is a software platform that we've developed, and it's used by hundreds of companies and businesses around the world, from agriculture to logistics to maritime to transportation authorities to cities and states. It's a software platform, and again, it converts weather forecasts into these actionable intelligence for different industries. Like I said, I'm going to speed through the self-serving part here. And again, just an example of the many different sort of use cases and applications and industries. They're able to use this type of information, and in particular, I work closely with our group that works with cities and states, and like I said, transportation authorities, coastal areas. We're working with the city of Miami right now. Again, to convert this weather information into weather intelligence that they can use to take smarter actions. Okay, so that was about what can we do with the information that we have today. Unfortunately, the information we have today is not good enough, and we all know that. We just saw the example with Hurricane Ian. We see examples, unfortunately, almost every other day, or certainly every week, of a weather event, often infused or impacted by the broader impacts of climate change that we're just not able to predict as well as we want to and need to limit the impacts. And so one of the most important parts of that is what we saw on the earlier slide. You have observations, you have models, you have machine learning, computing capacity. So observations is that first step, right? And what you see here is a map on the left of just ground-based radar installations around the world. You can see, as we all know, a robust network in the United States and in Europe. Outside of those areas, not nearly as good coverage. In many areas, almost no coverage, and of course, no coverage at all over the oceans. So, and this is radar installations, but it's representative of a lot of different types of observations, right, that are really centered on sort of the areas of the world that have the most resources, the most political will, and so forth. And so when it comes to radar in particular, radar is the most important tool we have to measure precipitation, and precipitation was one of the most impactful weather hazards, of course, that we deal with. And so what Tomorrow.io has gone out to do, we have this technology to convert what we have today, the information we have today, but how do we make that better? And so we are partnering with the U.S. Air Force. U.S. Air Force is helping to fund the development of the first 4 of our Tomorrow.io weather satellites. We're also partnering with NOAA. I'll talk about that in a second. And we are launching a constellation of radar-equipped and microwave sounder-equipped small sats. This will be starting in early 2023, so coming up early next year will be our first launches. And these will provide, with those 2 instruments, we will provide coverage, global coverage of precipitation, as well as a number of ocean parameters for sea state and sea currents and tides and so forth, with a revisit rate for any given location of every hour. And that's probably the most important part of this, is that revisit rate. This builds on technology, this builds on decades of investment by the US government in satellites like the GPM satellite that NASA flies. But the previous satellites are one-off satellites. They are focused on research, right? They provide high-quality data, but with revisit times of 2 to 3 days, because they're just single satellites, which is perfectly fine to do that research, to do that R&D. Not as helpful if you were trying to run an operational weather model and feed data into models that are running every 6 hours or even every hour, some of these models. And so that is where this constellation is really going to have an impact in improving that data and then improving forecasts. And then we get back to, once you start improving those forecasts, you still need to be converting those forecasts into that weather intelligence, right? And so just a couple of relevant examples, especially to the oceans and coastal community, of how we expect our satellites to improve the information, again, with this near real-time global precipitation and ocean data, applications such as maritime, really picking out where today you have a lot of blind spots over the oceans. You'll be able to find where are those areas of intense convection going to be that may necessitate rerouting, right? And take that proactive action before you're in trouble. Same thing with tropical systems, hurricanes. So improving intensity forecasts. Again, we have good radar coverage over the land in some areas, but we have to fly hurricane hunters out to fly in the middle of storms in the ocean to really find out how strong they are and get the position fixes that give you the better forecasts. This is going to help. Hurricane hunters can only go out so far, right? This is going to give us better coverage globally to improve both intensity forecasts and hurricane forecasts back to the cone. How do we we've got to shrink that cone, and maybe the cone isn't the best way to be communicating. That'll be figured out over the coming months and years, but at a high level, we've got to shrink that cone. We need more confidence earlier on in a forecast to really be able to take the right actions. And it is these different applications that has caught the interest of NOAA as well. We have a CRADA, Cooperative Research and Development Agreement with NOAA to prepare for this satellite data, to get their systems ready to ingest it should they wish to purchase it. Same with the U.S. Air Force, working with them to prepare should they wish to purchase some of this data. We'll of course be using this data in our own forecast models and systems. And so it's these kinds of partnerships, right? We couldn't do this. Maybe we could do it without the U.S. Air Force and NOAA, but it would certainly take longer. And so it's these kinds of partnerships that are really important because it's that timing. We have to accelerate how fast we're moving because the weather is moving faster than us right now. And it's going to take these kinds of partnerships to be able to keep up and maybe even get a little bit ahead of the curve.
That's terrific, Dan. Thank you. And I think it's a great example of how working with a government agency, NOAA, not only can a company advance its technology, but then when it gets deployed, go in turn help that agency perform its mission better. So awesome to see. Well, now we have about 15 minutes for questions, and I have a few in my list, but I'd like to get the audience involved if there's anything anyone wants to ask our distinguished panel. Oh, someone's coming up. All right. No, it's actually, no. Oh,
all right.
It's competition.
Good morning. I'm Dave Drazen. I'm with the Naval Surface Warfare Center at Carter Rock. And so my question was, as a working capital fund organization within the government, I don't always have a lot of ability to send money out. We're doing a lot of work. It's not always aligned. So my question really is how do we see value in a federal government to private industry partnership that isn't necessarily monetary related? How can we be better partners and how we might collaborate better? So thanks.
Thank you, Dave. Seems an open-ended question for many people maybe here. Anybody want to take a crack?
I'll take that one. Thanks. And thank you very much for your questions. So I also came from a lab, a government lab, a Navy lab. And that was my big question, being mostly a researcher and thinking, okay, I get to embark in research. We have all these great industry partners and academic partners right around the place that I was working. But it was very difficult for me to understand the tools that the Navy has specifically to foster those relationships. I would offer you a few ways of looking at this. So from an O&R perspective, there is a litany of different programs that allow us to really use our labs as the fingers and toes of the organization. So having technical expertise and points of contact at different labs to run things like CRADAs, any kind of cooperative R&D agreements, usually takes a little, cash in pocket. That's where you have O&R program officers that it takes very little to advocate and get you those kinds of dollars to support CRADAs, to support coalition warfare programs and CWPs. That's more of our O&R global pieces that we do. But really, sometimes all it takes is a single program officer saying, that's important to me and that's important to my portfolio. It doesn't take a lot of skin out of the things that are already happening. So those are just two examples, CRADAs and CWP. Are ways to start the conversation. And then that can flow back into what is the core portfolio, what is the core program doing, and then moving forward and doing enduring international type experimentation. Thank you.
Thanks, Emily. Anybody else want to cover? Jeff,
Yeah,
sure.
I can amplify that. So sort of from the operational perspective, the last talk was a good illustrative example of how to communicate that. So I think what your question gets at is sort of value proposition. You talked about money and some of the mechanics of how it does or doesn't move and discretion that you have. But the Admiral, remember the bluff. Bottom line up front. So the Tomorrow I.O. example, data in, measurements, lots of stuff, lots of important science. And at the end, bottom line up front, you should move your submarines out of port tomorrow because there's risk of something happening. And so as you go to engage across the warfare centers, the ONR, program officers, industry partners, performers that you might be working with, if you can explain or quantify the change in outcome of how we do it now to what we might be able to do better, faster, more insightful in that sort of and what you get framework. So current job, we deal a lot with the budget and trying to either defend or justify an investment in one thing or another. And frequently the conversation comes back to, look, what you're buying is labor and parts and contracting time. But what that buys you is we can make better decisions in faster time, more accurately, and there's a conversation to be had on the specifics. It'll depend on the problem. But you know, the type commanders or the system commanders be able to help you frame that in terms of, and if you could say, batten down the hatches and move the submarines out of harm's way 3 days faster, I can tell you how much it costs to operate a submarine per day, per unit time. And you can frame that in something that's quantifiable both monetarily and then bottom line operationally. That tends to be a more productive conversation than the intangible sort of level of effort. So again, back to your question on value proposition, yeah, there's a money aspect and discretion and ability to move things around. However, if you sort of think with the end in mind of why are we doing this, what does this actually provide value for, again, the Navy or partnerships or whatever, that tends to be a more useful conversation.
Perfect, Jeff. Thank you. Anybody else want to try to answer that?
I just want to say one thing from an industry standpoint as a technology developer, depending on when you kind of catch them at their technology development stage. For example, the work that we started with NOAA 5 years ago, initially we were offering the DRIX for use for 20 days out of the year. That did not involve any monetary transaction because at the time our goal was to advance the technology, get usage, get feedback, most importantly because it was a brand new system. So we needed user feedback in the field and also understand for ourselves what are the improvements and enhancements that can be made in the future improvements. So, and out of that came a lot of, for a lack of a better word, marketing and communication material, which helped us tremendously on a larger scale. So again, there are no monetary terms in that, but from an industry, we benefited from that collaboration without actually receiving monetary.
Exactly. And go ahead, Dan, you want to pile in
Yeah,
there?
I'll just add to that, just to sort of flesh that out a little bit more. I mean, yes, in general, money speaks, but there's more than that when, again, from the industry perspective, especially emerging and growing companies, you know, those companies need to show their investors that their technology or their capability is desirable, there was an urgent need for it. And so even when there isn't necessarily a monetary component to that relationship, if investors can see from a very important customer, whether it's the Navy, NOAA, so forth, that real interest, that real hard concrete interest, then that helps galvanize support from the investor community, which is what makes everything go in the private sector for these new and emerging companies.
Yeah, and I was just going to say from like a contractor perspective, as Linker has grown with NOAA being one of our most important clients, our goals have really aligned with what NOAA's mission and goals are itself. And so we end up having initiatives as Linker that are an extension of what a lot of the things are that we're learning through working with folks at NOAA. in fact, you might wonder, why is the name of the company Linker? And one of the things that we've been able to offer is just to be the conduit to connectivity. And we've done things in certain regions or line offices in partnership with NOAA that we've then been able to say, oh, well, we have this other contractor group in this other line office of NOAA that's struggling with something similar. And so you get these value adds that don't cost any additional money, just because we're able to help NOAA know what they're doing in other regions and other areas. And then take it outside of NOAA and taking some of what NOAA would love to do on a small scale local level, but Linker's able to do that where NOAA's not necessarily. So.
Thanks, Laura. That was great. What a rich answer to such an important question. Yes, sir.
Yeah, great. Thank you all for the conversation. It's great to hear. My name is Greg Sinnott. I'm a new research director at a small nonprofit, the Walter Monk Foundation for the Oceans. And my question is related to how you identify and kind of break off a chunk of work that you're looking for collaboration on, kind of outside the normal stream of collaborations that you already have. And after you've identified that, how do you advertise that you're looking for a new collaboration or you're looking for a new perspective? How would a small organization such as ours know that you're available to collaborate with?
Okay, thanks. Is it Rick?
Greg.
Yes. All right, Rick, great. The Monk Foundation's very near and dear to my heart as well. Any takers on this one?
Sure, I can,
okay,
I
Laura,
can start. We have done this a lot in the Pacific, and usually what happens is we'll attend a conference like this and just let people know that our company has a program and is open to what does your organization want to do, and then how can we increase capacity for you. And so one of the things that we've really championed ourselves on is what we call elastic capacity, in that, for example, we supply fisheries observers on boats to NOAA, and folks go out for a month at a time or so, but they don't necessarily want to be living on a boat 100% of the time. They're trained marine biologists, marine scientists, so we had nonprofits that would approach us and say, hey, we want to do this bay cleanup project, but we don't have the workforce to do it because we have an executive director and one or two folks in a board, and that's it. And so how can we do this? And so a lot of times we have nonprofit partners that are in communities where we have offices or field locations, and they'll reach out to us and say, we want to do this, but we don't have the capacity. How can we partner with your company to do this? And then also just through our website, we have a partnership page on the website where you can reach out and ask to be a partner. But we really take the lead on what other folks want to do, because if you're passionate about it, we usually have a resource that can get behind it, and we can work on it together.
Thanks, Laura. That's great. Jeff?
Yeah, at the end of the day, it's about whatever relationship you can develop with the other community. And so, back to the point I made, conferences like this, amplifying the point just made, are where you start to put faces with names. There's a number of tools that are impersonal. So there are small business innovative research opportunities. You can Google for it. There are broad agency announcements. You can Google for it. There's a big fedbizops.gov website, and you can precision keyword search your way through that. And those are useful. They'll give you data, I'd say. Sometimes there's some information and insight in there, but what you want is really to make the connection. So, opportunities like Linker that have a pre-existing relationship or existing contract vehicles with scopes and ceilings would give you a sense of winnowing down from ocean. So what does that mean? Well, sensing. Well, what does that mean? Sensors, single crystal, winnowing down from a big picture down to, I have a research scientist that is able to speak to that or has some expertise there. So find a friend, make new ones, and then, like I said, there are some of these other automated impersonal tools that are a good place to start. But really approaching somebody that has an ongoing relationship with the research funding side of the house is a way to get your foot in the door. And then there's always an expansive nature of, we didn't know you were interested in that. Oh, we work on that. And things just sort of snowball from there.
Nice, Jeff. Thanks a lot. Emily?
I'll just amplify on the SBIR, the Small Business Innovative Research, as well as the broad agency announcement. These are cyclic methodologies by which you can reach people within the ONR enterprise, meaning program officers, or our performer base, which is much broader than just ourselves. What we normally do, so SBIRs are run out of ONR, but all of the Navy uses them. So we have NAVC that can put in topics, and we do these topic calls a couple times a year. They're extremely responsive. We usually put in topics that we don't have room within our own core program, or it's a collaboration, say, like, I really want to work on particular pieces of glider technologies. I know the physical oceanography guys have the kit, but I'm interested in actual measurements in this way or using them in an ocean engineering format. We'll put something in as a topic and say, we'd like to see what industry and academia have to bring to bear. And we'll do like a phase 1, just a small amount. There'll be a number of studies, but that starts the conversation. And then what we'll do is pull in those SBIR workers into the programs we're already running. And so it becomes part of a very long iterative conversation that broadens the base overall. And then, of course, the BAA is pretty impersonal, but it's always there. You can put in any topic that you want, really any topic, and it will get to the right portfolio where it needs to go.
Thanks, Emily. That was great. I'm going to end it there, but thanks, everybody. And a final answer for you, Rick, is you could hire a consultant like me. All right. My good buddy, Dan Sternlicht, Dr. Dan, is going to close the panel out.
Wow. Admiral, distinguished speakers, what a fascinating discussion, right? And I really appreciated the dynamic between government and industry here, especially focusing on this theme, really the keynote theme of the day, of securing the future by strengthening our partnerships, right? That's what it's all about. I also appreciated the earlier dialogue between NASA and NOAA. I thought it flowed into this panel really quite nicely. So for the rest of the day, we have a set of lunch and afternoon activities, continuing another of today's themes, and that is women in leadership. Okay, we have a luncheon coming up in women in leadership and becoming an entrepreneur, and that starts actually very shortly. There is an innovation theater going on in the exhibit hall, and the foundation of this conference, the technical paper sessions. Make sure you attend as many of these as possible, as it is really these sessions really where the future of our capability in ocean technology really resides. So my co-chairs, Captain Ray Toll, NASA's Laura Rogers, join me in thanking all of you on stage, all of you in the audience, all of you online for making Oceans 2022 such a success. And we invite you to come up, meet our panelists, and let's give them one more round of applause. Thank you very much.